So let's continue on from where we left off. We've been talking about how urine is formed. We've looked at the first process, which is ultrafiltration, and now we're going to move on to selective reabsorption. Now we've just seen that in the Bowmans capsule, let me draw the Bowmans capsule, ultrafiltration takes place. Right, you have your glomerulus here, and some of the components of blood are filtered into the Bowmans capsule to form a filtrate. What does that filtrate contain? Well, hopefully you still remember that it contains all these small molecules that are able to pass through the wall of the glomerulus. And those small molecules include water, glucose, amino acids, mineral salts, nitrogenous waste products like urea. Now remember, this filtrate is on its way to travel through the kidney tubule and on its way to becoming urine. So think about it. Look at all of these substances in the filtrate and answer the question for yourself. What happens if all of these are passed out as urine? Do you see any issue? Now hopefully you realize that there's some pretty important substances in the filtrate. And if these are passed out through urine, then we're going to lose these really important substances like glucose, amino acids, and even water. In fact, if all the water in the filtrate were removed as urine, you would be really dehydrated. You would lose all the fluid in your body and look a bit like this poor chap here. So not all the filtrate becomes urine. And therefore, there is this second process called selective reabsorption, where some of the important substances are actually reabsorbed from the filtrate back into the blood. Right? So in ultrafiltration, a lot of substances are filtered out into the Bowmans capsule. That's ultrafiltration here. But in selective reabsorption, some of the important substances are selectively reabsorbed back into the blood to be held and to be kept in the body, whilst the rest are then passed out as urine. Okay, so what is selective reabsorption? Again, let's come back to this diagram here. Here's our glomerulus, here's the Bowmans capsule. So recall that there will be ultrafiltration here. This is ultrafiltration, right, taking place. The filtrate is formed and it's now in the Bowmans capsule. It contains water, glucose, amino acids, mineral salts, urea, and this filtrate moves along the kidney tubule. Right, it moves along the tubule in this fashion, and eventually, when it moves to the end, it will go into the collecting duct to be passed out as urine. So what is selective reabsorption? It is what happens as the filtrate passes through the kidney tubule. So as the filtrate passes through the tubule, useful substances like glucose and water will be selectively reabsorbed back into the bloodstream. Now, as you can see, the kidney tubule is surrounded by blood vessels, right, capillaries. So there will be an exchange of substances, and substances will move from the kidney tubule back into the capillaries which surround it. And this is the process of selective reabsorption. Now, why is it selective? Because the body picks and chooses, right? I can decide I want to take back certain substances into the blood, but I want to leave certain substances in the tubule to come out as urine. So it's a selective process. Okay, so selective reabsorption begins as soon as the filtrate enters the proximal convoluted tubule. Now, inside the proximal convoluted tubule, all glucose and amino acids are reabsorbed by diffusion and active transport. So you can see here, glucose and amino acids are reabsorbed back into the bloodstream, and that is by diffusion and active transport. Now, I want you to be thinking, why active transport? Why? Now, that's because we need to reabsorb all the glucose. This is really important. Glucose and amino acids are important substances, and the body wants to retain and to reabsorb all of it. And to reabsorb all, you need to use active transport, right? Because at some point, when I'm reabsorbing and all the glucose goes into the blood, at some point the concentration of glucose in the kidney tubule is going to become very low, and to get back all of the glucose, I need to transport it against its concentration gradient using active transport back into the blood. Besides glucose and amino acids, most of the mineral salts, for example sodium ions, are reabsorbed by diffusion and active transport as well. And finally, water is also reabsorbed by osmosis, right? Because water only moves by osmosis. And in fact, most of the water, about 75% of the water in the filtrate, is reabsorbed in the proximal convoluted tubule. Now, interestingly, water actually follows the sodium ions. What does that mean? Now, think of it this way. If the mineral salts are being reabsorbed back into the bloodstream, so let's say sodium ions are being reabsorbed back into the blood, that causes the water potential of the blood to decrease, right? Because it's becoming very concentrated in ions, in fact glucose as well. So what happens eventually is water just moves along with that, right? It's reabsorbed from a position of higher water potential in the kidney tubule to lower water potential in the blood. So water just is reabsorbed by osmosis. Now next, in the loop of Henle, some water is reabsorbed. Now in the loop of Henle, only water is reabsorbed. No mineral ions, no glucose, no amino acids. And something interesting happens as a result. Because the loop of Henle only reabsorbs water and not salts, it actually helps to concentrate the urine. It helps to concentrate the filtrate, right? Because only water is moving out of the filtrate. So whatever is left in the filtrate is becoming more and more concentrated. So the function of the loop of Henle, one of its main functions is to concentrate the urine, to make it more and more concentrated if you need to produce concentrated urine. Now, why does this concentration of urine not happen in the proximal convoluted tubule? Well, that's because, if you remember, in the proximal convoluted tubule, both salt and water are being reabsorbed equally, right? About 75% of the salt and about 75% of the water are being reabsorbed. So it's like I'm removing an equal amount of water and salt from my filtrate. So at the end of the day, the filtrate remains roughly the same concentration. There's just less water and also less salt. But once it moves into the loop of Henle, only water is being removed from the filtrate. So the filtrate becomes more and more concentrated. Right, next, in the distal convoluted tubule, some water and mineral salts are reabsorbed. Right? So it's quite similar to the proximal, except that there's no glucose and amino acids being absorbed, because all the glucose and amino acids have already been absorbed at the proximal convoluted tubule. And finally, in the collecting duct, some water is reabsorbed. Now, as we'll see later, the collecting duct has a very important function in adjusting the concentration of the urine. So we'll see later in the next video how a hormone acts on this collecting duct, and the amount of water being reabsorbed in the collecting duct can be affected by this hormone to produce urine of different concentrations. Now that's different from the loop of Henle. The loop of Henle just concentrates urine. That's the only thing it can do. But the collecting duct, you can either choose to concentrate the urine more or make it more diluted, depending on the action of a hormone that we'll see in the next video. So after selective reabsorption, what is left in the filtrate? What is left in the filtrate that's going to become urine? Well, firstly, the excess water that was not reabsorbed, the excess mineral salts which are also not reabsorbed, so these are going to be going out of the body as urine, and also the metabolic waste products. For example, urea, which is still in the filtrate, will also be passed out through the collecting ducts as urine. Now, importantly, even though we saw that there was no reabsorption of urea, right? There was no reabsorption of urea in the entire tubule. And so in a sense, all the urea gets passed out as urine. But that's not the full picture. And if you ever go up beyond secondary school to learn about excretion in kidneys further on, you'll also learn that actually some urea does leak out of the collecting duct at the end of the day. But that's a bit beyond us. You can go read up more about it. But yeah, to make it simple, at secondary school, we just tell you, or we just learn that all the urea is passed out, that there's no reabsorption of urea along the kidney tubule. Okay? And it's at this point that the filtrate leaves your body, right, through the collecting ducts, into the ureter, into your bladder to be stored, and finally you have to pee. And so you pee, but make sure you pee in publicly acceptable and socially responsible ways, not in the swimming pool, for example. Now, before we end, I'd like to just leave you with something quite interesting, and it has to do with this really cute animal called a kangaroo rat. Now, if you have time, go and watch a YouTube video on kangaroo rats, and you can see them jumping around the desert. They're really cute. So they live in a desert where there's not much moisture. And if you look at the kidney tubule of the kangaroo rat and compare it with ours, you will notice some differences. So what do you notice? The most obvious thing is that the loop of Henle is much longer in the kangaroo rat. And that has to do with what we saw about the function of the loop of Henle. Remember, the loop of Henle only reabsorbs water, so it helps to concentrate the urine. Now, can you link that to the kangaroo rat? So why is it that live in the desert have longer loop of Henle? Well, hopefully you can make the link that in the desert, there's a need to conserve water. Right? There's so little water, so we need to absorb back even more of the water from in our kidneys, right? We can't just let all of it come out as urine, or the kangaroo rat would dehydrate over time. So that's part of the reason why they have a longer loop of Henle. So in the future, you might be interested also to look at the structure of the kidney tubule in many animals, and compare it and see, wow, the environment affects the kind of body systems that they have. So that's a really fascinating thing in biology. Unfortunately, you don't really have that much time to cover it in class, but something that you might really want to go and explore by yourself. Right, finally, I want you to go and do some work. So read your textbook, page 232. This is important. Go and look at what are the main components of urine. What is the main component? What are the other components? What factors might affect the composition of urine? And why do people with diabetes have glucose in their urine? You might have heard of this, but why? Okay, so go and read up the textbook and we'll come back to class and discuss it. Okay, that's all. Thank you for persevering through this. Let's keep going.